In this video, we're going to be looking at using Desmond to find an exponential or logarithmic model of a data set. And so here are the basic steps to use Desmond and to find this function. First, we're going to enter the table by clicking the plus button and then table. And then we're going to click on the next line and type in either equation, depending on whether we're doing an exponential regression or a logarithmic. And then we're going to substitute in the values of a and b given into the equation. And note here, do not forget the subscript 1 on your x and y in step 2. So let's look at number 1. So number 1, we are going to use Desmond to find an exponential model for the data. And this is the same data set that we looked at in our the previous video. And then we're going to use this model to predict the number of trampolines sold in the 8th year. So my first step is I want to transfer this data over to Desmond. So I'm going to click on this plus sign, click on table, and then start to enter in these points. So I have 1, 12, 2, 16. I'm going to go ahead and pause the video and finish entering this data. Okay, so I have the data entered into this table. Now I want to click onto this second line, and since I'm wanting to do an exponential model, I'm going to type in this y1 is approximately ab to the x subscript 1. So I'm going to click on y, and then to get that subscript, I can go to ABC and click on this AB button, and then click 1, hit the right arrow to get out of that, and then I want the approximately sign, so that's right here. And then put A, B, raised to, so I want to hit this AB button right here, and then X subscript 1. So I do that, you see the function actually draws out right here, and I can see that it goes through most of those points, and I get all of this, but I want to pay attention to my parameters here, which is A is equal to this 8.9726 and b is equal to this 1.40265. And so I'm going to use that to create my equation. And so I'm going to go ahead and just round this to the nearest hundredth, so I get that y is equal to a, which is 8.97, times b, which is 1.40 raised to the x power. Now, if I compare that to what I got earlier, I see they're pretty close, but they're a little bit different. My 8 value was a little bit smaller, where my b value here was a little bit larger. Okay, then it says to use this model to predict the number of trampolines sold in the 8th year. So I'm looking at the 8th year, and the variable that represents the year is x, so I have that x is equal to 8. And so I have y is equal to 8.97 times 1.40 raised to the 8th power. And so I can go back to Desmond and make that calculation. So I have 8.97 parentheses 1.4 raised to the 8th power. And if I round that to the nearest hundredth, I get that that is approximately Actually, I'm going to round to the nearest whole number since I can't have a fraction of trampolines. So it's approximately 132 trampolines. Okay, let's look at the next one. So the next one says the atmospheric pressure decreases with increasing altitude. At sea level, the average air pressure is 1 atmosphere. The table shows the pressures P in atmospheres at selected altitudes H in kilometers. Use Desmond to find a logarithmic model for the data of the form H is equal to A natural log of P plus B. Estimate the altitude when the pressure is 0.75 atmosphere. Okay, so I'm going to go through the same process, but this time my model is going to be logarithmic. So I'm going to go ahead and just change out my equation here first. So I have a natural log of x subscript 1 right arrow, plus b. And then I need to type in my table here. And so I'm going to go ahead and pause the video and enter in this table. Okay, so I have my table entered here. And when I come down here, I see my model, and it tells me that A is negative 6.45 and B is 0.86, and I round it. And so going over here to write my function, that means that H is equal to A, which is negative 6.45, natural log of P, plus B, which is 0.86. And so there's my function, and then the second part says to estimate the altitude and the pressure is 0.75 atmosphere. And so 0.75, that is my air pressure, so this is saying that P is equal to 0.75. So I find that H is equal to negative 6.45 natural log of P, which is 0.75, plus 0.86. And so when I do that, I can go ahead and plug that into Desmond. So I have negative 6.45 natural log of 0.75 plus 0.86. And so I get that H is approximately 2.72 kilometers.